This is going to be redistribution using our newfangled diamond formation. So the reason for this diamond versus topology 11, so if you remember, topology 11 looked, so we had a triangle here in the center. That's horrible drawing, right? So, and there's other crap to the sides. So the problem with this is there's no real chance of having redistribution problems with this particular topology because you don't have multiple points of entry and exit. Unlike our new diamond formation, you'll see that there are multiple points where we can get into trouble, like here. And basically all sides of the square we could get really jacked up with redistribution. Alright. It also allows us to set up a routing protocol. Let's say we'll do OSPF inside of here. And then what you could do is, let's say in this triangle here, you'll run RIP and see how things blow up. And then in a green on the bottom, you could run EIGRP here and see if that interferes. Another cool thing about this topology is that you can run, let's say, well, all of these have loopbacks, but let's say you run EIGRP over here, you run OSPF over here, and you run some other protocol over here. On router 7, you're going to see an equidistant path to that loopback because you have two equal cost paths of getting there. And what you could do with redistribution is you can play around with the metrics or some of the metric types to get one router to prefer another way. We might cover route tagging tomorrow, Jeff. Okay, so for today we're going to do basic redistribution. We're going to go over, main thing is OSPF, getting things into and out of OSPF. We'll go into EIGRP. We'll also do, probably we'll do a little bit of RIP, so we're going to take it easy. And then tomorrow is where we are going to do multiple points of redistribution in and out. And we'll do filtering and route tagging and some of the other more complicated stuff. So first of all, let's set up our favorite routing protocol of choice, OSPF, inside of our square here. So we want OSPF running right here. And we just want the loopbacks in OSPF, but we also want all the internal links. So fast01 and fast10. You'll notice for every single router, those two interfaces are the same. Right? So rather than using network statements, what could we do to make this really, really quick? How could we do this? If we, let's say, go into our scripting, our amazing notepad or whatever notepad you're running. So I run Kate. So I've just fired up so could I do this? So enable Conti, we know we have to start with that. Right? So yeah, we're gonna set up OSPF on the interfaces themselves. So usually you're gonna do like, this is how you would usually do it, like, you know, something like that, right? You're gonna do that. But in our case here, since we have interfaces all around our square that have the same numbers, so 10 and 01, and also loopback 0, we could actually shorten this thing up. So paste in one config into all of our routers. So interface loopback 0, right? IP OSPF 1 area 0. So remember, this is process 1 and you're throwing it into area 0. And int fast 10 ing, yeah, ing, int, and int fast 01, right? Copy that. So that is how everything should look. and you could add an end after that. So this throws in the loopback 10 and 01 into OSPF. So we're going to copy that and throw them into, make sure you throw them in the right router, so it's 2, 3, 4, and 5. Okay, so 2, 3, 4, and 5, and just wait for your OSPF to catch up. So you'll probably see me mute myself several times tonight because I'm sick, fighting off this flu or cold or black plague or something. So I have to pause to get a drink or eat a cough drop or something. Okay, make sure your OSPF works by going on R2, show IP OSPF neighbor. Should have 3 and 4 as a neighbor. And if you're on router 2, you should be able to ping the loopback of router 5, which is all 5s. So if you can ping there, that means your OSPF is working. Now, as you may have noticed, your OSPF didn't come up right away. Who can tell me why that is? Why doesn't it come up instantly? Yep, that's true, and it's also waiting for DR BDR election, and it's going through its dead timer while it's waiting for that. Okay, so we have our OSPF running on the center. Life is good. So what we're going to do is we're going to run a routing protocol up here. We're not redistributing just yet, but we're going to run, let's see, oh, let's make it democratic. Let's vote. We're going to run a routing protocol on these links. So in the chat window, vote for your favorite routing protocol. So got EIGRP, oh shit, ODR, EIGRP, EIGRP. Okay, EIGRP wins. So OSPF is running here. We're going to run EIGRP over here. So on router 1's easy. It's just going to throw everything into EIGRP. So router, EIGRP 1, network, all zeros, and no auto, right? We'll just Hail Mary on router 1. Because as you can see, there's no other routing protocol interface that could possibly go into any other routing protocol, so just Hail Mary that sucker. And another cool thing about this router diamond pentagram ninja star thing is that if you screw up here, no big deal. Don't need to reboot. Just go down here or go to any of the other points and start messing with stuff. Mess up on one section, not a big deal. You don't need to reload GNS3, just go somewhere else. Okay. Now on R2, we're going to be throwing this section into EIGRP. So what we're going to do is, actually before we do that, let's go back to R1. Start a debug IP routing. And now let's go back to R2, conf t, router EIGRP 1, no auto, and network. If we want to throw exactly this guy into EIGRP, what command should we type in, or what digits should we type in? Yeah, let's match it exactly. So 10, 1, 12, 2, 0, 0, 0, 0. Yeah, 5 zeros, 4 zeros. Okay, so before going to router 1, R1, you'll notice has a neighbor change. Now you have to debug IP routing in there, so you can see when routes are added or subtracted from the routing table. The reason you're not seeing anything is because other than this link right here from R2 to R1, R2 is not actually putting anything else into EIGRP. So it's just that link is getting thrown into EIGRP. He told R1 about it, but R1 saying, well, I already knew about that, so big deal, right? Now we're going to go over to R3 and throw that link into EIGRP. So go to R3. EIGRP is fast, neighbor comes up, life is good. R1's going to see another neighbor come up. Of course you could verify that with show IP EIGRP neighbors, and you got 2 neighbors. Show IP EIGRP topology to look at the EIGRP table. Let's see what we got here. We got ourselves our own loopback, the connection to R2, and the connection to R3. Okay, so far, any problems? This is not even CCNP. This is CCNP level stuff. We haven't redistributed anything yet. We're just running 2 routing protocols, completely separate. Okay, let's go to R2 and let's take a look here. Let's take OSPF and chuck it into EIGRP. So we're going to redistribute O, that's a horrible O. We're going to redistribute OSPF into EIGRP. So if we are redistributing into a protocol, so we want to take O routes and pop them into E, we have to go into the EIGRP process. So router, oh, we're already there, but just for practice. We go into EIGRP, and who in this room has never done redistribution before? Like, you've never typed this command in. Okay, so that's good. I don't need to explain like every possible thing. Now for those of you who have taken or will take your CCNP route test, there is I won't say there's a lot of redistribution, but there's a couple questions on there. But it's not a big deal. Okay, so we want to redistribute, and we're taking stuff from OSPF. It's going to ask you the process number, do a question mark. You've got a metric and you've got match. So what this match is for is you'll see that you can choose to redistribute just internal, you could choose to redistribute the external or the NSSA external. And you'll notice here that you could type internal, external, just like give me all type thing. Right? But if you do that, you're going to get the internal routes, which that's all we have right now. You also have the metric, which you have to use. Now you may be wondering, okay, what's, really what is the use of this metric command? I'll tell you what the use of this metric command is. It's very simple. Because I don't think they explained this in any of the CCNP Academy classes, or they don't really do a good job in the Cisco Press books of doing this. So you've got OSPF here. Eventually you're going to run EIGRP kind of in this triangle here. O routes are going to go in on both sides. It's a horrible arrow. So O routes are coming this way. EIGRP routes are going to go into OSPF. Now later on we're gonna take R6. We're going to take the loopback of R6 and we're going to chuck it into whatever protocol we're going to do down here. It will probably be RIP, because I love RIP. RIP is awesome. Alright, so let's throw it into RIP. We're going to do some redistribution here. So we got these two routers here. Initially, router 1's going to see this loopback of all 6s. It's going to see that loopback as equidistant, so it's going to have two paths of getting there. Left or right, right? Now, we're going to do redistribution on these two routers, and we're going to eventually redistribute with different metrics. So on one of them, we're going to redistribute, and we're going to use a metric of 1 1 1 1 1, right? So 5 ones, which is really crappy, right? And on the second router, we're going to redistribute with the metric of 100,000 and then all ones. So that first number there is the bandwidth number, right? So higher bandwidth means it's juicier, it's better. And then so whatever router we type this second metric command on is going to be the preferred way that router 1 will exit towards that particular route. So you're actually going to see that in action. So that's why we have that metric command in redistribute. Okay. So redistribute OSPF 1 metric. So for now we'll use 5 ones. It doesn't really matter what you type in there. You're just saying, because in this case we only have redistribution on one router. Okay, now router 1, something has happened on router 1. You can see that router 1 instantly, maybe not instantly, but pretty quickly, he got the loopback of router 2, he got the loopback of router 3, loopback of router 4, and the loopback of router 5. He also got all of the internal links. So basically what happened is that was known with OSPF and that got chucked into EIGRP. That link. So all these links that were running OSPF. Okay, so that's a big reason why we run debug IP routing is you could actually see this crap happening in pretty much real time and go, oh, okay, I see what happened. There you go. It gave me all my links. Now, without even typing in ping, if I tried to ping from router 1 going to the loopback of router 5, what's going to happen? So, if you show IP route all 5s, you'll see that you got, oh, geez, would help if I did it from router 1, right? Show IP route all 5s. Right? You see it through EIGRP. It says you know it distance of 170 because it's external, and I'm getting it from router 2, so that's good. Now it won't ping, so why won't it ping? From router 1's perspective, it's good. Yeah, so R1 knows about the 4 routers in our square, but our 4 routers in our square, well, actually 2 of the routers of our square, 3 actually, don't know how to get back. So depending on how you ping towards router 2, you might be able to get back. So we need to tell OSPF EIGRP routes. Right? So we need to go on, let's say, router 2, go back on router 2, go into OSPF, and chuck EIGRP into OSPF. That way these guys know how to get back out. So it can be a little confusing in that, okay, am I going in or out? You know, so the way to remember is the routes that you get in determine how you get out. So what you get into yourself determines how you exit. And because the people in our central square here don't know how to exit, any ping from R1 will die. Because the ping's going to reach R5, and R5's going to say, well, that's great, but I don't know where to go. So let's go on R2. We're in OSPF, so that's fine. Redistribute, EIGRP1, and if you do a question mark, subnets. We're going to use the word subnets. Because if you don't use the word subnets, you're going to see something very interesting. You're going to see that you may not get all of your EIGRP prefixes into OSPF. So you're going to need the word subnets. You see the word tag in there, you see the word metric. For now, we're going to just leave it like that. Dirt simple redistribution. Correct, it does use the classful behavior. So let's take a look at our topology. Notice the IP addressing inside of our wonderful ninja star of death here. What's in that first octet of all of our inter-router links? So it's a 10, right? So, you know, we're trying to do it as a /24, but if I do redistribution in here and say, well, yeah, fine, just summarize everything to the 10, what's going to happen to my entire network? It's going to blow up because I won't be able to reach anywhere. And that's actually why I decided to go with this IP address scheme. That, in addition to 10 is easy to type. I didn't want to do the 172.16 stuff. Okay. So now if we go to router 5, he's all the way in the corner. We probably should have done debug IP routing on router 5, but that's okay. Now if I show IP route on router 5, I got some O routes. Of course we always had O routes. We have these E2 routes. E2 routes, yeah. So these E2 routes came from router 1. Now router 1 and then the top of my square there. And it's saying I have two ways of getting there. So let's take a look. If I want to ping the loopback of router 1, I can get there through router 3 or router 4. So let's see. So that guy's my exit point. I can ping out this way, or I can ping out that way. And so let's see if we can actually ping that guy. Ping 1111. And we have a success. Now you can also do the more complete test, which is ping all ones, source loopback 0. Make it come back to your all fives address, and you have a good ping. Now here what you're doing is you're doing a mutual redistribution. You're popping routes into OSPF, and you're throwing routes into EIGRP. So you're throwing routes both ways. Now as long as you're doing it just on one router, you're fine. Life is good. No problems. Now guess what we're going to start doing on router 3? We're going to start doing some redistribution on router 3. We're going to start with, let's see here. Let's throw EIGRP into OSPF. Yeah, okay. So let's think about this. We got EIGRP going to OSPF that way. We're now going to take EIGRP and throw it into that way. And on this side, on R2, we're throwing OSPF into EIGRP. Well, let's see what happens. Let's go into R3. Conf T, router OSPF 1, redistribute, EIGRP 1, subnets. Hit enter there. And if you go to R5, you have that debug running. Now you'll see something interesting. We'll see some changes happened. Mostly deletions. So it deleted a possible path to the loopback. It deleted a possible path to the 13 subnet, and deleted a possible path to the 12 subnet. Let's take a look at our diagram here. So before we were just redistributing here, and so R5 had two possible ways of getting out. So now what we've done is we're redistributing here. So if we're redistributing on R3, do we need to go all the way to R2 anymore? Yeah, so it's closer for us, or it's faster, closer, lower metric, whatever, it's better for us to go out towards R3. And so since R3 is winning, that's where it deleted these paths that way. And that's where you see this deletion here. Deleting that, and deleting that. So now if you show IP route, this is how your routing table looks now. This right here, you're headed towards R3, which is the upper right corner. Whereas before in your show IP route table, you had two possible ways of getting there. So in fact, we could do this. Show IP route, all ones. You'll see that it is an external of 2. This forward metric is 1. So what the heck is this forward metric? Well, this means if you're comparing multiple ways of getting out. So if the subnet mask is the same, so longest match, that's the same. Your administrative distance is the same, and your metric type is the same, then we go into the forward metric. So 1 is going to beat a 2. Now, all of these are fast Ethernet links, so in OSPF, all of these have a cost of 1. And just to prove it to you, let's go back on R3, hit the up arrow, and kill that redistribution. So no redistribute 1 subnets. Go back to R5, you'll see that those routes are added back in. We hit the up arrow. Now you see a forward metric of 2. And that is because you are going, you're going 2 links away. Does that make sense to everyone? So that forward metric, not a lot of books or videos talk about this guy right here. Like, you see it, but it's like, what the hell does that do? Okay, so Jim has a question. He's not getting 1111 in the routing table. Okay, so let's take a look at your screen here. And wait for Google Hangouts to catch up. Okay, so looking at Jim's screen, you do have loopback 0 in there. Okay, so that's good. You have router EIGRP, you're throwing everything into EIGRP. So on router 1 you're good. Now let's go to router 2. Yep, so Jim's looking at his EIGRP. Let's see, so you have redistribute OSPF, so you're popping OSPF into EIGRP, okay. You threw, network 10.1.12.0.0.0. So do this. So instead of doing that to show IP EIGRP neighbors, just to see that if you have R1 as a neighbor. And so you see right there, R1 is not a neighbor. So then you would do, that's where I would check the EIGRP network statement to see if you have the same thing. So it should be 10.1.12.2, all zeros. So you had 10.1.12.0, which you don't have, so the Cisco router said, well, nothing matched, so I'm good. Yeah, and I'm pretty sure after you do that statement, then you should be okay. Yeah, and it's probably because you're so used to doing /24 that maybe muscle memory, kicked in. It's like, oh, okay, 0 in the 4th octet, all zeros. Okay, so a couple questions about the forward metric. So Jeff is asking for me to go over it again. That's fine. We could do that. And Mark says, so a forward metric of 2 means 2 hops. Well, not exactly. In our case here, if you notice, go on R5, and if you show run interface fast00, you'll see that every one of our links has speed 100. So with OSPF, if you've studied CCNA, actually you should have learned it in CCNA, the bandwidth determines the metric in OSPF. And it's based off of a 100 meg link. So if you make the link 100 megs, the metric of that link, or that cost of that link, is 1. Right? So in our case here, with this particular topology and these particular speeds, this metric, this forward metric, is essentially a hop count. Right? So that's why we did the speed of 100. Now watch what happens here. If I go to R5 and fast01 and fast10, right? So let's change that. Let's go to interface fast01, speed 10, interface fast10, speed 10. Everything's going to drop. Show IP route, all ones. I'm going to have to wait for all my things to converge. So here what you see is my forward metric is now 11. So why is my metric 11 now? Well, that's because I changed the speed of my links to 10. So 10 megs. So if I take 100 megs, yeah, let's do it that way. So 100 megs, if you divide by 10 megs, that gives you 10. But all I did was I changed these links. These are 10. But these links are still what? They're 1. So 10 plus 1 gives me 11. So the forward metric, all it is, it's a cost of getting out. How do you get out towards this guy? Another way of looking at it is, what is your cost of getting to the ASBR? Correct, the OSPF cost of a 100 meg link is 1. And 10 megs is 10. Does that make sense? Yeah, 10 to the 8th divided by the bandwidth. Okay, so Jeff asks, if we changed the metric type from type 2 to type 1, would that forward metric be changed? Well, let's see. Let's do it. First of all, let's go to R5. Let's change back our links. So it's fast10, speed 100, interface fast01, speed 100. So change back the speeds, which will change the cost. You can see all this craziness happens because now it's going to be recalculated. So if you show IP route, all ones, your forward metric is 2. Okay, so this is how we look right now. We're going to go to R2, hit the up arrow, redistribute EIGRP1 subnets, do a question mark. So now by default your metric type is an E2 route, so it's an external route, and the metric does not change, so it stays 20 throughout. That's the default. So let's see if we could change that. Let's change that to a metric type. Change it to a 1. Now we type that in. We're going to wait a couple seconds. You can see R5. We have some magic happening at R5. And you can see now this 20 has changed to a 22. Show IP route. Notice what happened here. Your metric is a 22, and it stripped off what? What used to be here? Forward metric is gone. The forward metric is gone because you're not using the forward metric anymore. The whole reason of adding to the metric for a type 1 is to get you out, is to have the complete picture of how to exit. So when you have that complete picture in the metric, there's no reason to have a forward metric right here. So if we scroll up, so before you had metric of 20, forward metric of 2. We go down here, we got metric 22, type external 1, and nothing after that. Now another thing you can kind of look at is if you take the metric here for a type 2 and you add in the forward metric, you're gonna get this. They should always equal up. So this metric 20 plus 2, that's 22, is equal to this if it's a type 1. Now, for those of you thinking about CCIE, what things they're going to throw at you is there's going to say set up redistribution so that on R5 when you type show IP route whatever, that you will see this particular metric, this type, and this forward metric. They'll make you do it so that they're looking for a specific output, and so you have to kind of work backwards from there. They do some weird wacky stuff. They'll also make things like in the QoS section, they'll say make it so that every 9th ping dies towards R1's loopback. It's like, the heck? Okay, let's go back to R2 and we'll redistribute normally with the type 2. And let's show run pipe S OSPF. So you see redistribute EIGRP metric, geez, gotta pop a no in front of there. Just can't overwrite that. My config was just not letting go, so I had to blow away OSPF. Okay, finally. Yeah, that might have been it. Okay, so now we're back to normal on router 5. So show IP route, all ones. I gotta wait for my thing to calm down there. Actually, hold on here. Oh, look at that. That's another thing I should have explained. So you notice that on my router 2, while I was fighting with that, I did a no router OSPF. Now I had the IP OSPF commands under the interfaces, and so notice what happened there. When I did no router OSPF, what did it rip out from my interfaces? It ripped out all associated OSPF, yeah, so IP OSPF 1 area 0. So that's just something to be careful of if you do that. So now I just have to add in fast10, fast01. And pop my loop back into there. Just setting a reminder to myself. As I just realized that even though I'm pausing or muting myself on Google Hangouts, that my Camtasia is still recording all the audio. So we definitely don't want those sounds going in the recording. Oh man, yeah. Okay, so R5 show IP route all ones. Okay, so traffic share count is 1. So from R5's perspective, we have R2. Remember, we've killed the redistribution here. So we have 2 ways of going out. Now, if for whatever reason your question says make R5 prefer this bottom path, and you're only allowed to touch R5, how could we do that? We want to make it go down the bottom path, and we can only touch R5. What could we do? Modify the cost, that would be one way, yeah. Make the metric, make it a better metric, yeah, we could do that. Actually, that's probably the way I would do it. Now let's think a little bit, that's actually what we're going to do, but for those of you guys going for CCIE, when you're asked that type of question, you have to think a little bit more outside the box, because what they're going to do is they're going to have restrictions on that. They might say, do it, but don't modify the cost. And, you know, they'd be like, what? That's how I'd normally do it, right? So the most extreme would be, which would definitely not be allowed in the test, would be shut down interface fast10. Would that get you through the bottom? Yeah, it would. I could lower the cost on one side, or I could raise the cost on the other side to make it worse. You know, there's probably a couple of other ways of getting there, but you know, let's go with the cost. Let's go the easy way. Now, let's say, now if we go and we look at the show IP route again, to see the cost of your link, show IP OSPF interface brief. All of your links right now cost 1. So can you actually go lower than a 1? Yeah, we could put a static. Yeah, because a static would beat OSPF. Like I could do this, right? We could say IP route 111.255.255.255.255, and then what would my next hop be by looking at the diagram? 10.1.45.4. Yes, correct. Okay, so before you type this in, what's going to happen when you put this IP route command in? What kind of mixed martial arts fight will happen between static routing and OSPF? Be careful with that. So this is a static route. So we know that from our decision making thing, when you decide where to route something, you have longest match. That's first, right? So longest match. This is coming in as /32, I think, in OSPF. So I think in that case, let's just verify that. Yeah, so you see right here, OSPF, we know it as a, I think we know it as a /32, show IP OSPF database. Okay, so if you actually want to see the actual LSA, show IP OSPF database, external 1111. And so, okay, OSPF is sending it as a /32. You're putting it in as a static route /32. Longest match, they tie. So longest match, they're the same. Then we go with administrative distance. So OSPF has an administrative distance of what? 110. Static routes have an administrative distance of 1. So 1 is going to completely destroy 110. Like, no contest. So now if we go on router 5, show IP route, you'll see, let's see here, so we know that, hold up, show IP route, what's going on there? Oh, did I cancel my statement? I didn't type it in, look at that. Correct, only the all ones route will be replaced. There we go. Okay, and since you have the debug IP routing command on there, you'll see it gives you the exact reason right here. Closer administrative distance for all ones. Winner. It's a static route, and so it killed 2 OSPF paths going towards all ones. So it knocked it out of the routing table. So your debug IP routing actually tells you what's going on. So now if you show IP route, you'll see all ones is right there. So that administrative distance of 1 is the thing that blows it away. let's kill that static route. And you'll be able to see the debug IP routing kick in. So you delete it, and then these come flying back. Okay, so another way of doing it is to modify the cost. Now we know we can't go lower than a 1. So if we can't go lower than a 1, we can't really make one side directly better than the other one. So I have to make another side worse. So I need to raise the metric. So I need to go on this guy, fast 10, and raise it. Yeah. So go on fast 10, IP OSPF. Now you could do process ID, but IP OSPF cost. Now all you need to do here, you don't need to do some crazy amount. like don't use that link ever. You know, whatever, right? So you change the cost that way. You wait a couple seconds and then your OSPF table temporarily goes nuts. And so now if you show IP route, you're going to exit towards router 4. Correct, 65,000 is unreachable. So you know, the 65,000 command that I used, it's kind of dangerous because if you have a big topology and you have routers past router 5, you could actually black hole stuff. Okay, and that's exactly why I am going to nuke that cost. So take out that cost command, fast 10, pop a no in front of there. Okay, so Sheldon asks, could we, another way to accomplish it, could we redistribute EIGRP into OSPF with a higher metric? Now let's see here. Okay. So yeah, once we get into redistribution on 2 points, yeah, so that's one way of picking exit points. But for now, we're just dealing with R2. Okay, any questions so far? Okay, speaking of R3, let's finish up. Let's go to R3. We killed that redistribute EIGRP into OSPF, so let's redo that. Redistribute EIGRP 1 subnets. And router 5 will get a better path over to R1. Show IP route 1111. I now have a straight shot to R3. So right now, R5 is going out that way. It is still getting OSPF updates saying that, you can reach R1 the long way around. So right now this is a total cost of 2 right there, right? So it's 1 for here and 1 for there. This guy right here is just 1. Now there is a rule in OSPF that type 1s beat type 2s, regardless of cost, regardless of metric. R3 is redistributing into us as type 2. That's the default. What do you think will happen if we go on R2 and we redistribute as a type 1? Now remember, these guys, it's farther away. R2 is farther away. But what happens if we redistribute as a type 1? Well, the rule says type 1 beats type 2, right? Now let's try it. Let's go to R2. Router OSPF 1. Kill that old redistribution. Redistribute EIGRP1 subnets. Metric type 1. Immediately, R5, we've got that debug running. You can see it's deleting the route going through R3. It's adding a new route going through R4. Show IP route, all ones. And you'll see, let's see, router 3. Got that guy right there. So that all ones route, or that type 1 route took over. Type 1 external. So now it will prefer router 2 to get towards router 1. Type 2 is default, so you actually have to change it to type 1 to get it to change, or to get the redistribution type to change. So type 1 beats type 2, regardless of cost or metric. So this can get a little confusing because a type 1 beats type 2 even though the type 1 has like a 60,000 metric. Okay, let's go back to R1, or not R1, sorry about that, R2. Hit that barrel, kill that redistribution, and just do redistribution EIGRP1 subnets. So just like normal. Go back to R3. We're going to go here. Now if you want to see what redistribution is happening, you can show IP protocols. And you can see under OSPF, you'll see redistributing external routes from EIGRP1. More specific way of doing that is you could do show IP protocols, pipe I, redist. Now you'll notice that under EIGRP we're not doing any redistribution, right? So we flung RIP into here, not RIP, but EIGRP. We've popped OSPF into here, and we've popped OSPF into here. We just need to complete part of the puzzle. Now so far everything's working fine. Not a big deal. Let's see what happens if we go on R3 and redistribute into EIGRP. We have a debug IP routing on R1, so we're good there. So redistribute OSPF 1 metric all ones. That's the same metric as the other guy. Immediately R1 lights up. Have more routes. Add. So immediately right here you can see show IP route. Let's go look at all fives. That's the loopback of router 5. And we have a, see, we can hit router 3. Next hop is router 3 to get there. Now, let's show IP EIGRP topology, all links to see everything in our topology table. And so let's see, we're going to 13.3, out fast Ethernet 0.1. And that is our huge, humongous metric right there. Okay, so there's a question, should we have equal cost load balancing if we set the metric value to be the same? Well, let's see. If you look at your topology, you're probably wondering, well, why am I not seeing R2 and R3 as next hops to these guys right here, right? What's going on there? Well, to truly see what's going on, let's go to R3. Let's show IP route, all fives. Copy this to your notepad. Okay, so I copy that to notepad. We'll go back into our routers. Go back to R3. Actually, I should have done that on R1. Sorry about that. Show IP route, all fives. Okay, that makes sense. All right. Wow, still copying the wrong. Okay, finally. It's always fun when you're playing inside of VMware. Okay, so we'll go to R3. Here's what we're going to do. We're going to stop the redistribution into EIGRP so that redistribute OSPF 1 metric all ones. Now what you're going to see is you're going to see that route going through R3 So R1 to R3, that should drop off, and it'll go back, transfer back R1 to R2. We'll see that's the case. Basically, you know, they all die. And now we'll show IP route, all 5s. Gotta wait for this to catch up. Show IP EIGRP. Oh, we still have a neighbor. Come back, R1. Clear IP route star. I'm going to forcibly clear my neighbors on R2. Okay, let's see what we have on R1 now. Show IP routes. That EIGRP is not happy between R1 and R2. Anyone else getting the same issue? Okay, so let's troubleshoot. This is interesting. So all we did on R3 is we took out the redistribute OSPF into EIGRP. That's all we did, and everything just kind of blew up after that. We go in R1, show IP EIGRP neighbors. We have 2 neighbors, so we're good. We go to R2, show IP EIGRP neighbors. We're good there. Show IP EIGRP topology. We are seeing stuff coming from R1. Okay. Show IP EIGRP topology. So for some reason our connection between R1 and R2 got rocked, like for some reason. We've already cleared the neighbors. Let's do it again. And let me just make sure we didn't foobar anything. If we show run pipe S router EIGRP, okay. Something happened there. Okay. That was weird. Okay. Okay, so we were missing a redistribute OSPF1 metric all 5s on R2. Which actually makes me believe that possibly we were missing it all along. So, go back to R3, redistribute OSPF1 metric all 1s. Yeah, well, you know, stuff happens. We do it live. Okay, so now we're okay. So now if we show IP route, let's see what we got. That's what we should have. Yeah, I was kind of worried. I was like, It's kind of weird. Okay, so you notice that to R5's loopback, show IP route, all fives. We got two ways of going there. We have the exact same metric. We have load sharing. And so now, to end the night, we're going to go on R3 and we're going to make R3 the preferred path on getting out for R1. It's very easy. I showed you that before. If you go on R3, if we kill this redistribute statement, hit the up arrow, change that 1 in the front. You don't have to go all crazy, but let's say we change it to 1000. Basically, you're making the bandwidth higher, and if you make the bandwidth higher, the metric gets lower, right? Higher metric is bad. So if you make the bandwidth better, you actually change the metric and make it better, which is lower. Kind of, sometimes it's opposite thinking there. Whoops. Yeah, that's not going to do anything. Remove that no. Go to R1, show IP route. We have one way of getting to R5's loopback. Metric is definitely lower than the 2 billion or whatever it was before. And we're going through R3. You see right here, minimum bandwidth, it's now 1000 kilobits, whereas before, where it was getting jacked up is minimum bandwidth is 1 kilobit. Any questions about that? So if you go on your redistribution points, so you go here, you go here. Alright, there's a triangle right here. If you make the metric 111, the redistribution metric, the same, R1 is going to want equal path. It's going to want to load share out. But if you go on either router and you change it, better or worse, you actually can't make it worse than a 1, so you have to go on the router and make it better. Then R1's going to pick that better path to go out. Any questions so far? So I hope that they'll probably wrap it up for tonight, because I'm about to face plant into my keyboard. But hopefully this type of topology helps you out a lot, and it's very interesting to see how you get to particular loopbacks. Tomorrow what we'll do is what you could do to shortcut everything is you can load in the OSPF core one, and that has OSPFs already it's already set up in the center here. And what we'll do is we'll do EIGRP up here, and we'll throw RIP down here, and we'll see how things fight. And then we'll throw we'll probably throw another EIGRP here as well, just to play around. So before we sign off, any questions? Yeah, that CCNP class 2 video, that never got recorded. I think that was the one where we went through the whole class, and then at the end someone said, hey, did you have the record button pushed? So I don't even remember what we did for CCNP class 2. Yeah, we'll redo it. Not a problem, we'll redo it. Probably in May. Okay, so that's it for CCNP route redistribution part 1. Tomorrow will be part 2. I know the actual name of tomorrow's session is layer 3 path control, but that's part of redistribution. It's basically changing the metric types, tagging, filtering, all that good stuff. Alright, and as I said, the recording of this should be available in about 2 to 3 hours. Everyone have a good night.